So we're going to do something pretty non-standard, I guess, with this guy. We're going to go ahead and put a completely, well, 90% box stock MR03 onto this. And the main problem with this is that this is designed for LiPo, right? You can see. And this is designed for AAA. And 4 AAAs is 6 volts, whereas a 2S LiPo is 7.4 and fully charged is 8.4. So that would not work with our electronics. We'd probably end up frying it. So what we have to do is we have to down volt it and use a BEC. So that becomes a problem as well because we don't have a lot of space in here and we don't want something big. So we have to find a BEC that is small, and we'll take our LiPo down to 6 volts. So we've got one on the way, and we will show it later in this video when we get to that point, and hopefully that will work. But for now, we're gonna go ahead and take this apart and see if we can get it all put onto this chassis. So there's our rear pod, and now we're gonna go ahead and pull out the electronics, the board, and the servo, and then put it in this guy. And there's our front end, all taken off. We won't need any of this. Well, we'll need the wheels and tires, but that's it. Now we want to get this out. We like to try to put screws back where they came from for the most part with stuff like this, just so that we don't lose them, or if you've never taken one apart, this will help you remember where stuff goes. And now, yeah, pull the ring out. We should just be able to push it out since we took the bottom screws off. And we have a full assembly. And we should just be able to drop this straight into there. We also need this front bit. That'll keep our body on. So generally, people convert the Evo, so the MR03 with the Evo board. The MR03 is the chassis platform. It's pretty much just the standardized chassis, and then the electronics are the box stock or the Evo, things of that nature. There's different electronics packages that you can run. So this is really a conversion for, they say, any MR03. But again, you'll probably have to make some adjustments like a BEC or minor adjustments to what you're trying to run. But we'll see. This should go in pretty smooth with just the addition of the BEC. That's my hope. These front springs, they just pop off the back of these screws here. You can just kind of push them back and they'll come right off. We are going to have to take this whole front end apart. That's also kind of, I guess you have to do it on the stock one, but I guess it's to be expected. I was hoping this plate was separate. We could pop it off, but these things are small, so they have limited space. I guess the easiest way to pull this guy apart is to just pull out our pins here. See, there are little grub screws. Yeah, so our front A-arms are just little grub screws in there. Actually, we're just going to go ahead and pull it out this way through the knuckle and not mess with the A-arms at all. right, so we should just be able to drop our servo gearbox in here. Actually, we don't need to pull that out. And I'll tell you what, it is a very tight fit. The tolerances are very, very tight here, which is a good thing. All right, nice. Here we go. Hopefully I don't think we dropped onto it. It's okay. We'll pop this off. So this is one of the benefits of this BiSon, is that this front plate, unlike the Skylines, just comes right off. So you can adjust your steering bar here. So on the Skyline, this is one piece. The whole bottom chassis is one piece. So to change this, it's a real pain. Whereas on here, you just pop it off and get your change these out for different toe. But we're going to use a stock one for now, whatever it came with. I'm not sure the length here. This is a narrow front end. I think they make it narrow just so that you can, because you can put wider offset. It's probably easier to put wider offset on here than it is to take a wide and narrow it. Then you're limited on your chassis. Or you're limited on your bodies, sorry. Alright, we should be good there. Everything looks correct there. Throw this back on. I think everything on here is a 1.5 millimeter. So, well, not everything. Obviously, the grub screws are much smaller. And these front shock screws may be a different size. Let's see. No, they're also 1.5s. Yeah, I think everything's 1.5 except for your little tiny grub screws to hold in your kingpins. Or I guess they're not. What are these? These are your pivot axles, pivot shafts, A-arm pivots, whatever. These guys here are held on by a grub screw. Now what's interesting is there's not really much holding the servo in place. Once we put our servo housing back on, it should hold it pretty tight. There is a cutout here for your servo wires. Make sure you don't pinch them. Okay. Yeah, and now our servo is held in place pretty well. All right, cool. Again, this is our first time putting one of these chassis together, so you'll have to bear with us. Now, the best way to do these electronics is probably going to be something like this. Side to side. We will pull this guy off here. And I think we're going to try to mount him. We don't have a lot of room here, or a lot of length on our wires. Let's see. What's the best way to go? Our motor wires are going to run through here. Do we run them out the back? Will this fit like this? I guess this will fit like this. We'll just have to resolder. Once we do our LiPo stuff, we'll have to resolder this. I guess we can fit like so. As long as we're not touching on our servo. We don't want to short anything out on the servo, because the servo housing is metal, the motor for the servo. I think that'll work. I think we can just basically put it back in like stock. All right, we're going to go ahead and put our front back together here. Did we fall off? We might have fallen off. What the hell? All right, we'll have to take this plate back off. Let's just get this front end done, and then we'll look at that. Remember, don't ever over tighten this stuff. If anything, use a little tiny bit of blue Loctite. Don't use blue Loctite where there's plastic though, because it will degrade the plastic unless you have plastic safe Loctite. But if you're going metal into metal, you should Loctite some of those spots. If you notice the screws backing out or getting loose a lot, you probably want to check after your first run. You know, if this is all new and put together, check after every run just to see if there's screws backing out, and where those screws may be backing out, you might want to just put a little dab of Loctite on there. Again, a little goes a long way, and only where metal goes into metal. All right, so our front end is done here. Our servo is in. Oh man, looks like we broke a wire. We'll have to fix that. One of our servo wires broke off. That's what we get for manhandling it. Not having our electronics mounted, but we're gonna have to do some work on here anyway. We'll probably remove our power switch and just bridge this circuit here and have it permanent on, because there's no reason to have on and off switch. You always pull your battery out anyway, so we'll probably do that. All right, so front end's good to go. We just got to put these two screws back in. This board actually lost its antenna, so at some point we probably should resolder an antenna back on here. It seemed to be working just fine. We've been running it for months with no antenna, so I wasn't too worried about it, but we should probably put an antenna on there at some point. All right, we got our servo wire soldered back on, and we're going to go ahead and just do a test. I'm going to go ahead and hook these back up to the stock chassis and power the board just to be able to see make sure our steering's still good. I like to test things along the way. It's kind of harder on these, but on the SEX24s and some of the other stuff, it's a little bit easier to test that stuff along the way. But let's give it a look. Remember, this side is your negative, this side is your positive. All right, so we appear to be good here. So that's good. And I'm sure that the motor will still work. And yeah, so we just got to get our BEC, switch it over to LiPo. We'll leave this on here for now. I don't know. We'll see how things fit in there. But yeah, we're halfway there. Hopefully we're more than halfway. We'll see. All right, we went ahead and just bridged it, removed the power switch, so now we're permanently on. You can see we are still good to go. Well, there we go. And we'll go ahead and throw the rear on. Remember, these T-plate screws for this are fine thread, so make sure you're using fine thread screws. The coarse threads are for plastic. And we're probably going to have to pop this all off again when we start working on the board again. I just want to get this together until we get the BEC. Do it like that. We want the shorter. We could have used the Nexx plate here. I just didn't want to take this all apart. We've got the Nexx disc dampener plate and the brace, but I figured we'll just use this. Should be just fine. All right, let's get our fronts on, our front tires. Well, wheels and tires. Oh, that's right. So I forgot that these front axle shafts are the 3mm versus the box stock is a, where'd they go? There we go. It's a simple 2mm. So there's a difference there. So you have to use 3mm ball bearings. You can't use the 2mm. They will not work. So we gotta swap those out. We just happen to have some 3mm bearings. 3 of them. Let's go ahead and throw these guys on. Sorry, Nexx. It's what we had. It's what we had. If we had Nexx ones, we would use Nexx ones, but this is what we have. Remember when you're popping bearings out, pulling bearings, you kind of work them out. Don't force them. You don't want to damage the inner ring on the bearings. When you push them out, you want to evenly push them out. It's not so bad on these because you're plastic wheels, but on the SEX 24s, we have aluminum, sometimes brass, and they stick, and you got to give them a little bit of force. And so you want to make sure you don't damage your bearings when you're taking them out and putting them in. Whoa, we got a hitchhiker. Get over there. Same when you're pressing them in, you want to evenly kind of press them in. Look at them go. Still going. Still going. Looks like they're still going. We don't have time for this. But they're still going. Well, oh, look at that. There's a piece of tire hanging out. Oh, man, okay. Go away, stock parts. Go away. I do like that these axle shafts are a tad longer. That way your wheel nuts don't come off. That is nice. I know this isn't quite the right size. It feels like this. My other tools upstairs. All right. She's all mounted up. Seems good. Box stock rear end. I know it's not ideal, but we'll get there. Seem a little low in the front. Maybe not. I don't know. We gotta get our front body mount. I think we're good though. It's hard to see without the light. We don't have the best lighting here, but I think that's good. We'll have to tinker with it once it's actually running, but so far so good. So I wanted to get a weigh-in before, and I totally spaced it out. So let's just go ahead and do one now. This is an LM chassis, so it's similar as far as just having the extra here, and we've got the transponder on there, and we're looking at here. Let's do it this way. 85 grams, and then this guy here. Throwing our front body mount on. Now this is minus the BEC is 95 grams. The thing is, it may be a little heavier, but I think once you have the LiPo in there versus the AAAs, your LiPo is going to be a little lighter, and your center of gravity is going to be much lower. Also, this is going to be much more balanced. So from the center here, you're going to have a little bit better forward bias, right? Especially once we have the body clip on there. Not that that matters much. And the transponder towards the front. It's going to just be a little bit more. Plus we can mount the BEC to the front. Whereas this guy is very, very rear heavy. It's going to be much more kind of rear biased. And once you have the AAAs in there, it's going to be much heavier. And the center of gravity is not going to be very low. So that's a benefit here. If we stuck an aluminum pot on the back and whatnot, it would probably be a little bit more rear biased. But I think overall it's going to be just a more balanced and hopefully better performing. Partly because of that balance. And then partly because ideally the suspension here will be a little superior, but in the LiPo, obviously. Like I said, lower CG is big. That's kind of what we're going for here, is the lower CG. So we'll see. So we had to snag up some more Nexx parts for the BiSon build. Well, later. We needed this now. But this stuff's for when we decide to go not box stock. And so we figured to pick that up now. And this is for our local shop, and they had it. And yeah, so we're getting there. We just got to get our BEC, I think, now, and some batteries that fit. Batteries are proving to be a pain. They, that little aluminum block in there, kind of rough. And then the Lambo doors, if this was forward just like a millimeter, I don't know what the second hole is here. The top, you've got 2 holes. I don't know what the second one's for, but if this Lambo door was just a little more forward, you could fit the normal batteries that you run in all the other chassis. So like we mentioned, they had sent out a pre-production chassis for us to check out, and there were a couple things off, but it all got fixed, and now we have the rig running as it should be with our batteries able to fit. We're running the normal PN batteries here. They totally fit. When we were testing, we had to run them kind of slanted in there, and the upper deck was set for a 2S, and then we could kind of slide these in and get them to fit. But the problem was, like we mentioned, these were too far back, and so the batteries had to sit at an angle, and they didn't sit completely flat. But they sent us a new chassis out, chassis plate, and again, the holes are forward. They also had to send a new upper deck as well to adjust for the top holes here. But it's all good now, and it's running good. Now, in the next part of the video coming up, we go over the BEC that we were going to use on this rig. We ended up not needing it. After I did a bunch of research before, and it seemed like everybody was saying you got to use a BEC, you'll fry the boards. But come to find out, you don't need the BEC. So unfortunately, we did all this and found out we didn't actually need it. Part of what led us to our answer, however, was the fact that the BEC was causing interference with our antenna and the receiver. So we would get kind of erratic throttle and steering the further away we got from our box stock remote. Then we went and used it on our Noble NB4 Pro, because we've got the little module that goes in there to run box stock, and it ran better. It didn't have as much interference, but still when we got towards the furthest part of the track, it started getting erratic, and that's how I figured out that it was an interference issue. We had the BEC basically just sitting right on top like so, and that was causing issues. So we moved it and kind of pulled it back while we were at the track, just kind of got it as far away as we could, and it seemed to improve it, but there were still issues. So that's when we started digging even deeper, and someone was finding like, we used to run LiPos on our 2S LiPo on our box stock, and we never had any issues. So I said, let's try it, and we tried it, and it's been working. Let's keep going though. You can use the chapters below to skip over the BEC portion if you're not interested, but if you are interested, BECs are very cool, and they have a lot of applications. And I'm sure there's a way to make it work on this if you want to downvolt to 6 volts, because the 7.4, I'll tell you what, it is super fast. It is not box stock anymore, that is for sure. So we got our BEC in. It's the NSD-RC BEC. And basically, it's going to go where power goes, and between power and battery. Should be pretty straightforward, and there shouldn't be any issues. I think the main concern here is where we're going to mount it. But let's go ahead and hook it up and see if we can run on a LiPo. So generally what a BEC is used for is powering a servo with more power than what your radio or ESC would use. So if you have as an example, your radio and ESC is supposed to run on 6 volts, but you have a more powerful servo that runs on 7.4, you would use a 7.4 battery and then downvolt your ESC and receiver with the BEC. We're going to use this to downvolt our LiPo from 7.4 down to 6 for the stock internals on this guy, because the stock Kyosho board is designed to handle only the 4 AAAs, and that's 6 volts total, but a LiPo puts out as much as 8.4 volts. So this is going to help take the voltage down to 6 volts even, so that we don't fry the board. But these are used a lot in the rock crawler world, just for being able to run servos that have a higher requirement of voltage, because their servos need a lot of power, so they have a lot of torque in their steering. Anyway, so the first thing we want to do here is just go ahead and remove our old power wires, because we're going to end up hooking these 2 wires to the power input, and then our battery will go in there. It's pretty simple. We want to think about how we're going to have this installed in our car, essentially. So it's going to be like this. Okay. So we went ahead and removed the heat shrink. We put a piece of electrical tape on the back. We know these get warm. We want to be able to dissipate heat. Also, we are resoldering the way this wire is so that we can get a little bit better angle, because it's actually going to tuck under this way, because when you do this, you need to think about how your board's going to sit in your car. So we know that the board's going to sit this way. We've got our wire leads, or our motor leads here, and they're going to be tucked under like so, and our board should be sitting about like this, which means our power is coming through here. And then we want to think about how this is going to sit in the car, right? So we're not going to put it all the way up here. We'll probably put our transponder up there, our lap counter. And we don't want to put it anywhere else, really. It needs to be out of the way of the shock here and damper plate. So we're probably going to put it right here. That makes the most sense. So what that means is we're going to tuck our wire right here, our positive to there, and then we're going to wrap this one along into here. Okay? So before you start soldering and really cutting stuff, you definitely want to make sure you know how you're going to lay out your electronics in the car. Okay, so we're going to go ahead and solder this now and solder this, and then we'll try to power it on. Okay, there we go. Now we can tuck it under. And our board will go under here. And our battery leads, we'll probably shorten them up, but they'll basically go in here. All right, let's go ahead and power it on. We get a light, we have a remote here, and we have steering. So far, so good. Let's get our motor hooked up here. So some say you want to make sure that your motor wires are the exact same length. Just for the way the current flows through there, you want it to be the same amount of resistance. I don't know if that really matters, but we're going to do it anyway. So we're basically just going to make sure we're cutting it basically the same length, and then we'll tuck our negative back to here. You also want to make them as short as possible, so there's as little distance to travel as possible. But again, don't cut them too short, because there's no going back. You'll have to put new wires on if you cut them too short. We pulled off the original motor wires because we wanted to save the eyelets that were on there for if we bring this guy back to a stock chassis, we'll need those eyelets. Well, we don't need them, but we'd like to have them. And there we go. Just want to be sure that your wires aren't impeding your pod movement. We should be good here. All right, let's see if we've got juice. All right, sir, we got all of our, this is our box stock electronics, not an Evo board, box stock. Got our motor wired in. This is our BEC. We're gonna put it across here. We got some electrical tape on the back. We're gonna stack it on here like so. And then once we get our right batteries, we'll figure out our battery lead, but here's just a 30C 2S from an SEX24. Plug it in, we're lit, and we've got steering, and we've got go. It sounds a little faster than box stock, so that'll be interesting. We'll find out. I don't know if there's something else about the constant voltage out, or if we're getting a little bit more. This should be down to 6 volts. This is any number of volts down to 6 volts, which is what AAA's are. So, shrug? I don't know. We'll see. We just got to get batteries in there now. And I don't know if we're going to do 2 1S's. Probably 2 1S's just so they're balanced, because getting the 2S in here is going to be rough. So, yeah. Kind of exciting.
A few moments later.
Our final form of this this build is slightly different than what you saw, partly because of the battery situation, and then also because of the BEC situation. So we've been running it like this, testing it here and there, and this is running really good. We're really happy with how this is set up right now. You can see we're running 2 1S batteries for 2S, and we lowered the deck, the electronics deck here, to a lower setting. You can have it set, and then on top back here, you put the carbon fiber on top, or you can set it down on the post and run the lower deck to run 1S. So this is 2 1S batteries in a series. So basically you double your voltage. You take them from, a single 1S, which is 3.75 volts, and it doubles it, versus running it in a series, which is basically doubling your endurance or your MAH. So you could also run 2 2S batteries in here and run them in parallel versus in a series, and running them in parallel basically, again, just gives you double the runtime. So if you had two 2S batteries in here that were each 200 milliamp hours, then you would end up with 400 milliamp hours. Okay, so just a couple different ways to run your batteries. You can also see that we had to kind of mount this in a goofy way. This board, in hindsight, we'd probably mount it going across the car, but we didn't want to have to redo all of our wires, and we would probably have to extend our servo wire and the potentiometer, the servo motor and the potentiometer wires if we were to turn it. This is also, if you've noticed, and if you're paying close attention, a different board. So when we were testing it the first time with the BEC, and we had this sitting on top, we thought that we actually damaged the board or fried the board in some way, and that's why it was acting erratic. So we bought a new board, and, well, it was still acting erratic. So we realized also that was part of when we were 100% sure, okay, the BEC is causing interference, not just that we messed up the board in some way. So we still have another board. This board's still good. That'll go back in our box stock. We also rebuild the entire front end here. As far as the servo is concerned, we did all Delrin gears and a metal fourth gear, and I'll post to that video over here. It's going to be a separate video basically showing how to change out your box stock or Evo chassis servo box to all Delrin and metal gear. So we'll show that, but that's what's in here now. But this car is super fast. We're still tuning it as far as suspension and handling is concerned because it kind of traction rolls a lot, and we probably need to add maybe a little bit of weight at some point, or just, again, tweak the suspension. We had some major issues with our rear pod, so we just kind of got that fixed last night, and hopefully we'll run it again on our next Friday race just to test it out, and it should be running much better with the traction rolls and stuff. We're really excited, and we'll go ahead and show you some footage when we run it here right now.
Three. 5.
So we've had a blast with this guy. There have been some ups and some downs. Again, the fact that we got a pre-production chassis really kind of threw some wrenches in the mix. The fact that we couldn't get the standardized batteries to fit was an issue. We also had a front clip kind of issue, but they took care of us. Again, this was a pre-production. You're going to have issues. So, and we also took a non-standard route for building it. Right, we're using all box stock parts, and so trying to do the whole LiPo thing with the BEC thing, it got frustrating at times. But overall, at the end, it was fun. We had a good time building it. I think we're going to take this box stock rear pod off and get a different rear pod on there. Potentially, I'm not sure yet. We can't put a brushless in if we're going to continue to run this box stock electronics board, but I don't know, maybe we can figure something out. We do have a Nexx rear end that's meant for a brushless, but maybe we can fit a PN90 in there. I think we can. We might have to drill some special holes to mount it, but I don't know. Maybe we'll experiment with that. We do want to get our box stock that we took all these parts from back in. We did buy an extra board because, like I had mentioned, we thought we had fried one of the boards or messed it up, and turns out it was just the interference from the BEC. But yeah, overall, it's been awesome. The chassis itself it's a good chassis. I like it. It all depends on what kind of classes you run. Our local classes, unfortunately, we don't have the best place for this chassis in our local classes because all the way down to stock, we have box stock or what's called Hobbytown Spec, which allows you to upgrade some stuff on the box stock. But overall, it's box stock. Then we have the stock class, and the stock class, we pretty much can use any chassis. That includes a lot of the real low LCG chassis, which Nexx will be coming out with one, and I am super excited to check out Nexx's low LCG, basically supercar style chassis that you can run in super stock and mod and stuff like that. Because this chassis it's not going to hang in mod. It's not going to hang in super stock very well. You can run it, at least the way our classes are set up for mod and super stock. So we can probably run it in stock, and it'll go against some of those LCG chassis just fine. Again, it all has to do with how you tweak it. A lot of those stock cars in the class that we run locally are running a brushless 3500 but with AAAs, or a brushless 2500 with the LiPos. So there's not really a LiPo brushed class. So if I build it that way, I don't know what class we're going to run it in. But really, it's more just for fun and to show people that you can do that. And if your local classes let you run that kind of stuff, run that kind of stuff. It's pretty fun. And again, it's budget friendly if you're using box stock electronics and box stock parts that you already have. Pretty cool that you can slap them on a chassis like this, running a brushed motor and LiPo, and have a much better chassis to run on over the traditional, MR03 chassis. So, yeah, we'd recommend it. If this is the type of chassis you're looking for, then this is definitely worth looking at. This is far better than the Skyline chassis as far as being able to work on it. You can pop this off and swap out stuff, your steering link. I mean, overall, the chassis has some really great features. It can be mounted with regular plastic bodies, the regular Kyosho bodies or Lexan body. It's got a very low front system. And then the battery tray can be adjusted. We showed that for both 1S, and you can raise the deck for 2S. We mentioned the steering bar here. The ride height is adjustable. You can also adjust your caster angle 1 and 0 degree. It comes with some extra A-arms. The camber angle also 0, 1, and 2 degrees with the 0 lower arms, and then 1, 2, and 3 degrees with the 1 degree lower arms. You've also got quick adjustment between the 98 millimeter and the 102 millimeter, so you can easily adjust your length if you want to run a different body. And again, T-plate and gimbal motor mounts. It's also pretty low CG, and it's got 775 aluminum, all the parts, and carbon fiber and whatnot. So overall, we're liking the chassis. And it comes with a front end. So for the price, you're getting a front end, and the Skyline doesn't have that. But you can piece it together if you want it. There's pluses and minuses to both styles of chassis. Anyway, we're going to wrap it up. Like I said, we had a lot of fun just experimenting with this, and we're probably going to tear it back down and do something else with it. So this is the last time you'll see it in this form. And yeah, just with some tweaking here, we got it to handle pretty well, and it's way quicker. We had to put a 6-tooth in there. We had a 9 for a while, and it's just way too fast. We had some some major traction rolling issues, and again, a lot of it just took tweaking the rear end and getting our tires set up. We had to trim them down pretty good and super glue the walls and whatnot. The Delrin, we installed the Delrin and metal 4th gear, which are awesome. They really smooth it out, and we also shimmed the servo saver just a little bit, and shimming the servo saver takes some of the slop out of that front end. So we kind of recommend that on any car, whether it's this chassis or any other MR03 chassis. Get the Delrin gears, get the metal 4th gear, shim your servo saver. And we have a video on that right over here. It shows us installing all that on this car. All right, guys, get out there and run your cars. Smash them, crash them, bash them, and don't break the expensive parts. And don't forget, subscribe, like, hit the bell, comment down below, BiSon, if you're still watching. BISON, if you're still watching all the way to the end of this episode, video, show, whatever we want to call this, BiSon. All right, have fun. Make sure you spread the hobby. Bring somebody new to your local races. Make that a goal for this next month. Bring somebody new. Show them how to run it. Let them borrow a car. Get more people racing. Take care, guys.